Gunters, you always talk about how you're making this kind of amplifier, that kind of amplifier. And you also said that this amplifier can beat them all. Any high-end amp, even one costing 10,000 euros. Well, tell me, why will this amplifier beat them all?
Well, when we say it will beat them all, yes, that's a very, very serious statement.
Aggressive.
Aggressive, aggressive. But maybe let's just clarify. As of today, if we build something like this, well, very, very, I would say 90, 95. Well, let's leave 5% for dreaming, right? But 95 are rational ones that we can buy. Because the last 5%, they're not even twice as expensive. They're about 10 times more expensive. And the last 2%, that's just out of this world, right? That's already science. So let's settle for about 90% quality, right? Well, yeah, at that level.
All right, deal. Will cover 90% of the maximum possible quality with this amplifier. What should it be like?
No, let's maybe first clarify the requirements for a modern amplifier. Well, for the year 2026.
Let's do it.
I've put together a kind of overview here, and basically it covers everything: marketing, salespeople, the technology, and the requirements have to say. And let's do it this way. Well, there are quite a lot of points here, but you'll read them out and make a short, well, positioning statement. Sometimes we don't buy the very best, but we can compromise a little on some parameters. You just need to understand which ones. And we'll make the amplifier as good as possible, right?
All right, it's a deal. Key sound parameters are THD, TID, THD plus N. Excellent level, less than 0.003 in most of the power range.
So, THD. For a long time I wondered what THD was, and it turns out it's the Russian term for total harmonic distortion. Yes, you can look up this term in Russian. Total harmonic distortion is something every radio enthusiast, every music lover, every high-end seller knows. And here it says that an excellent level is 0.003. Well, what do you think? Is this kind of figure even achievable today?
I think it's absolutely no problem, because when the Japanese started mass producing their amplifiers in the 80s, they achieved even lower distortion levels, but as far as I understand, by lowering the distortion, they made some other parameters worse. I'm not very familiar with this stuff. How so?
Yes, it became slow. Very deep negative feedback slows down the amplifier. But today I'll say this is a very good amplifier, 0.003. And what do you think? How much is needed?
I think that even if the distortion is around 2 or 3%, well, we probably won't hear anything.
Well, no, that's for amplifiers. In general, according to science, when they actually did experiments on people, they determined that 0.25% is the threshold. And to be safe, the hi-fi industry said it should be below 0.1%. Anything below 0.1% no one will hear. If you set it to 0.04 or 15 zeros after the decimal and set it to, well, 0.07, right? No, 0.007, then we won't hear this difference. Both amplifiers are equally good buys, because sometimes we look and see there it's 0.003 and here it's 0.002, 1, or 4 zeros and 9. That's even better, yes, 4 zeros and 9. And for us it's like a red rag to a bull, and we think this one is better. And marketing says this one is better, but it's not better. Just a little bit, it's not an important parameter. Below 0.0, below 0.1, and that's it. That's good, but if you show someone brochures that say below 0.1 today, everyone will say that's not good. Bad, that's bad.
At the very beginning, you said that because of a very strong reduction of this parameter, the nonlinear distortion coefficient, amplifiers used to become slow. How does that work today?
Today, these are just good components, and we don't have to use such terribly deep feedback. Simply, all the elements are better and we make them correctly. There are also Chinese manufacturers today. I saw an amplifier, someone had one with 4 zeros and it was also class AB. They set the price at about 1,000, but it's pretty mediocre. Yes, mediocre.
So if you drive nonlinear distortion very low in class AB, it'll become sluggish.
But you probably won't hear it. Honestly, it's really hard to do. And you don't need to. It's much, much more important for it to be dynamic. Because we only need 0.1. But marketing is such a powerful thing. You wake up at night and say, no, I have a bad amplifier. I can't sleep. I want one with 4 zeros and a little more.
Well, that's how it is. Marketing works. That's its job. You bought one with 4 zeros and next time it'll say, no, 400 is bad. That's last century. Let's go for 5, 6 zeros.
Well, it's like with digital cameras, right? The pixel count started going up. Well, everyone who does photography knows that if you have a small sensor and too many pixels, which are shorter than the wavelength of light, the image just gets more blurred. And regular people sometimes don't get into this. Experts know.
Well, it's very easy from a marketing point of view, but from a physics point of view, these are completely different processes. All right, let's look at the signal-to-noise ratio, SNR. Excellent, 115, 125 decibels. What does this number mean?
Well, basically it means that we have a more or less powerful amplifier. It has low noise. You connect it and it doesn't hiss yet. Yeah? That's important, especially since we're getting a new type of speaker with horns, compression drivers, and a sensitivity of about 100, right? I think there are even higher ones.
It's rare for it to be over 100. I think I saw a speaker once with a sensitivity of 105, but that was something exceptional.
Yeah, but 100, that's a lot. And basically, if it has any noise at the output, it's going to hiss at home. You have really high sensitivity. Basically, if there's no need, a very, very sensitive speaker for home use makes things harder for the amplifier. You have to buy an expensive one because it will hiss, it will make noise. Its own noise level has to be very, very low, extremely low. That's, well, 30 microvolts or lower. And if you want a more powerful amplifier, that's an impossible task and it won't work out. Because when we make very sensitive speakers, well, very sensitive, like when you need to shout outside, there's never enough power. And if there's a little bit of hiss, like in a stadium, it doesn't matter. But at home you can hear it. That's why a sensitivity of 90 is ideal for a speaker. Lower isn't good either, and you don't need more than that.
Since we've touched on speaker sensitivity, sometimes they make small bookshelf speakers that have pretty low sensitivity, 86, 84, 88 decibels. Why is that done?
Well, I just don't know if the camera can see it or not.
It can, yes.
Here, for a 6-inch loudspeaker.
Yes.
But it moves very little air. It's not sensitive by its physical nature. And these speakers, they're designed to be used as near-field monitors. Near-field monitors.
Yes.
Up to 1 meter. And up to 1 meter is not a problem. Everything is fine there. With such a 100-watt amplifier, they'll sound very detailed and quite loud.
What about farther away?
Well, with each meter we lose 6 decibels. And considering that the amplifier's power and the sound in general, since there's a logarithmic relationship, yes, to double the sound pressure, we need to increase the power 4 times. Well, for example, here's an extreme case. 100 watts isn't enough. What's the logical next step?
Then 400?
400, yes, that's always the case. If 400 isn't enough, right?
We multiply by 4 again.
And by 4 again.
1.6 kilowatts?
Yes, but that doesn't happen. Usually it's enough. But in general, since the relationship is logarithmic, you won't get far with a small speaker. And such a small loudspeaker, it has low sensitivity. If you push it too hard, it also has its limits. These ones. But then we do it differently. Mostly it's bass, right? So we move them close to the wall. By placing them near the wall, we get an extra 6 decibels of bass. Well, let's do it this way then. So, where do we place the speaker? And then it turns out that if you bought a big expensive speaker and you have a fairly large room, you move it away from the wall, you lose all that bass reinforcement, right? And you need a very powerful amplifier. So I sold my amplifiers to people who bought big speakers, and they don't have any bass, so they replaced it with an even cooler one, and still nothing. It just can't control it, it's moved away from the wall and you need a lot of power. And suddenly they hooked up a more powerful amp and everything fell into place. So with a 100-watt amp, that's how it is. When it's close to the wall, everything's fine, but when you move it away, it's not enough, not enough.
The next parameter is dynamic range. Excellent, 120 decibels, and I'm really curious, how does this relate to amplifier's dynamic range?
It's also a ratio, basically, signal to noise, as they explained to me as well. So it doesn't depend that much on power. Like if you have a 200-watt amplifier TPA 3255, the noise should be 40 microvolts. And how much does the TPA 3255 have?
I don't know.
85. It hisses a little, even at home.
Uh-huh.
Yeah, that means you need a better amplifier there. The TPA 3255 doesn't meet that parameter. A sensitive speaker will hiss.
But an insensitive one won't. Am I right?
An insensitive one won't, yes.
Alright, the next parameter is the damping factor. A good one is 600, an excellent one is 1000. And I think, if I'm not mistaken, the damping factor in hi-fi, according to the standards of the last century, was 90. Or am I mistaken?
In general, there was a really good book on designing speaker systems. I think it was by Vance Dickerson. Well, it's the kind of book everyone should read if they want to understand speakers. And it said there that the minimum damping factor should be 10. If it's below 10, you can definitely feel it. You can work from 10. 50 is good. And anything above 50 or even 100, that's off the charts. And after that, it's just modern field effect transistors. Modern transistors, they can easily provide that. In general, I would say 50 is kind of the high-end limit. And if you look at a Macintosh amplifier, which has an output transformer for matching the load, it works at 2 ohms, 4 ohms, and 8 ohms. You can switch it. So its damping factor is 40. And nobody complains that it doesn't sound good. These are very expensive. They cost about 10,000, right? Macintosh. So this parameter is also just marketing. And everything there is more and more is just that modern MOSFETs do it easily. Especially in Class D. In Class AB, it's a bit harder to achieve.
Let's explain what this damping factor actually does, what it's for.
So its essence is a low output impedance. And we need it so that we can control the woofer. What principle does the woofer operate on? If you short its coil, yeah, it's like this. It's very hard to move. Well, you can move it, but it's hard to move. When you let go, it moves easily. And with this, if you have a normal damping factor, you fully use this force when you short it. It's not very big, but still, because it has to regulate for the impulse. Forward, backward, and then it stops. Well, it can't do it perfectly. It has mass, so it goes forward, backward, and just a little bit. And the sharper you can stop it, the clearer the bass. Otherwise, you get this kind of thump, and then another kind of thud. Thump, thud. A small difference, but emotionally it's big.
Yes, and I also read that the damping factor is necessary so that the amplifier isn't affected by the energy generated by the speaker when it moves back. There's a magnetic coil inside, and when it moves back, it generates energy. And this,
A good one.
goes into the amplifier.
A good loudspeaker handles this by using a shorting ring that absorbs it. Basically, not so much the amplifier. The amplifier controls this one more.
Movement.
Well, it's shorting. And the better it shorts, the more there is. But since this is a limited force, at some point it doesn't matter anymore. Still, you can push it with force.
Yes.
This is the maximum control that an amplifier can provide. And generally, a good one should have a shorting ring to reduce that.
Which doesn't let this energy go back into the amplifier?
Yes, it suppresses it. It had a specific name. I can't recall if it was a Faraday ring or something else. I might be mistaken. I don't remember exactly. Basically, there's a shorting ring in there.
Okay, all right, I see. The frequency response is linear within plus or minus half a decibel from 20 Hz to 20 kHz. Well, and there's an extended range from 60 to 80 kHz for high resolution. I mean high-res audio.
Agreed. Well, it's hard to say about the extended frequency range and high-res audio. In general, almost all amplifiers work up to about 50 kHz. Maybe there's a slight drop-off, but up to 20 kHz, that's really not a problem at all. Anyone can do it, and that's how it should be done.
Okay, intermodulation distortion IMD excellent, less than 0.002%.
Yes. And today, actually, this is an important parameter. And today, almost everyone does it. No problem. But this is worth paying attention to. It's important. What is this? For example, if you input, I don't remember, 11 kilohertz and 13 or something like that. Well, there's a small difference depending on how many spurious components are generated. And this is important. It generates different spurious tones. If it's small, then that's good.
Okay, so by the IMD parameter we also check and make sure that it's good. Alright, your favorite point is output power. For home hi-fi, it's 100 to 250 watts per channel at 8 ohms.
Let's stop here at 8 ohms. For 4 ohms, we double it. We get 200 to 500. That's what I was talking about, right? Where you get about 200 watts max from the TPA 3255. And it really can look clean, right?
With a good power supply.
Well, that's by default.
Uh-huh.
With a poor power supply, forget it. You can't do anything about it. If the power supply is bad, that's that. We're not even talking about it. So the second thing, for studio-grade high-performance active systems.
200 to 500 watts per channel, plus, after 500 you still have more.
Yes, what does that mean? It means if I want to reproduce it very, very accurately, I need some headroom. That's the bare minimum. Yeah? If you want, and all those who yell at me and say that I only have 15 watts and they play loudly, what's the difference between loud and precise? When the bass speaker can't do it, the mid-range speaker can. And with just 10 watts, the mid-range speaker will deafen you. But there's no bass anymore. And how does that show itself? Just recently, some guys took my amplifier for testing, and there was some Hagel, some old Superman, 300 watts. He says, you know, we tried yours across the whole range, and it always sounds kind of the same. But with that one, when you turn it up, the rock starts screaming at you. It screams, but yours is kind of the same everywhere, boring. But why does it scream? It screams because when it can't do the bass anymore, the mid-range comes out and it starts to scream. It just can't deliver that bass. It's very difficult. The hardest part is the bass. And a good, really good bass gives us a very strong emotional, like this is the kind of speaker that does that.
Feeling?
So S90, those distortions are about 5%. And the tweeter there isn't really that great. But everyone says, you know, I like it. But for me, S90 is below my threshold, where I feel, well, where I personally feel it, I need better. But the bass is good.
Many viewers ask why 500 watts per channel for home use, that's a lot.
Well, that's just a small peak for the bass. But you have to push a truck. Imagine you're at an intersection, you have a car, and there's a truck. The truck has a bigger engine, a more powerful engine, and you take off right away. But you can't push that truck, it'll just sputter. If you push it, there's a kick, it's sharp, it's nice.
Yeah.
Boom.
Yeah. Yeah, and nobody says you have to turn the knob all the way up and run it like that all the time.
You don't have to crank it.
500 watts is headroom. You set it to your 10 or 11 o'clock, listen at 70 to 80 decibels, and you always have headroom. When something happens, either there's an explosion or an event on the TV screen, or in a musical piece there's a kick drum hit or a musician's attack. The amplifier has the headroom to reproduce all of that, and you hear everything.
Well, so musicians have this big foot, you know, with their foot, the bass and all that.
Yes?
Boom. It's about like 80 to 120 hertz or so. That's it. You have a big short peak.
Yeah.
And to get that drum sound just right, you need a short high peak. Well, I don't know, maybe half a second or less, that's the whole process. But you have to reproduce that moment. Sometimes it takes 400 watts. And as it happens, let's say with Class AB amplifiers, do you remember before when there were a lot of them? Like Yamaha, the 230 model is 100 watts, then by 650 it's 110, right? And what do? You start from the lower end, you lift it, it's light, heavier, even heavier, 600 watts.
Nice.
Yeah. Everyone there has voltage for 100 watts, but the first one might be 35 and the last one there might be 70. So it turns out that what marketing said, but for the speaker to work well, you should never run it at more than 30%. Well, yes, that's how it works. And in Class AB, if you put an oscilloscope on the power rail, up to about 1/3 it stays flat. And then after that it starts to dip a bit. With every hit it dips a bit. That means it starts to dampen your bass. Your bass becomes, well, like I said, my Hegel is shouting, but yours is always kind of playing like that. Boring.
Flat. Boring.
Yeah, it keeps delivering bass, so the tonal balance doesn't change. But there, as the volume goes up, the mids start to stick out.
Yeah, there are a lot of nuances. Guys, write your questions in comments. If we get enough questions, we'll make a separate video based on your questions. So the next question is about power. This is the power for subwoofers from 500 to 2000 watts.
Well, yes, the lower it is, the more you need for it to work so well. Well, what do we do at home? We buy a 150 watt subwoofer and put it in the corner. If we put it in the corner, we get about +8 to 12 decibels at home. When you have 3 reflective surfaces, your floor, one wall, another wall, yes, 3 walls, you get a serious bass boost. And then 150 is enough. But if you take it out into an open field, then it's just pop, 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 pop.
There won't be enough power.
There definitely won't be enough. It's a logarithmic relationship. As soon as you move it away, yes, you lose 6 decibels and you need 4 times more power.
Electronic and engineering features. Power supply unit. The best option is a modern SMPS. With PFC correction, soft start, high efficiency and plenty of reserve capacitance.
Well, that's right. Modern components have all advanced again. Circuit design has moved forward. We have everything powerful and well developed. There are many chips that control SMPS, and we can make a really good power supply. Better than, well, for example, a large conventional transformer. Well, a good toroidal one. Why? Because such a toroidal transformer has a lot of turns, high internal resistance, high inductance. And here, well, can you see it or not? How much power do you think can be passed through this transformer in pulse mode?
I watched your video.
Well, you can run 5 kilowatts through it because it's a different architecture. There are 10 turns here and 3 turns there, and it has small losses.
Very small, yes, and it's small too.
Well, it seems small, you know, special materials and so on. In general, everything has moved forward. Why can't we use them in Class AB? Because they constantly heat up, they constantly consume power. It will also heat up a lot. Here's peak PCA. We only need it briefly, but at high power. Yes. PFC correction, yes, that's right, for high power. Because all these chargers, the ones like this, there's a bridge and a capacitor. The main grid senses it as a capacitor.
Capacitance.
Capacitive load, yes, as a capacitive load. Too many capacitive loads. Those who know about electricity will understand. There the phase shifts between voltage and current, and not all of it is used effectively. That's why you need inductive and capacitive ones. They compensate each other. That's because of the requirements, not the electronics. This is according to the requirements of those who sell us electricity.
Yeah.
But we also install PFC at higher power levels. That makes it inductive. There's a large choke there, and it senses it as inductance. Back when we had a lot of electric motors in factories with high consumption, well, that used to compensate each other. But now we have a lot of other things there, yes. A high efficiency of 92, 96 is very hard to achieve. I don't know of any powerful amplifier like that. Usually they're up to 90 actually. From 80 to 90, maybe 92. There are requirements, the ability to fulfill them. It's difficult.
Yes. All right, should we move to the next one?
Let's do it.
Amplifier topology. The best modern options. Class D, modern top-notch. Pascal Purifier Eigentakt, right?
Yes.
Eigentakt, Hypex Encore, Fusion, Ice Power, 1200, 2000.
Well, it's what we've already talked about. We can resist as much as we want, but this technology will come, right? That's also what all the reviews say. This technology is coming, and everyone will gradually switch over. Well, there's no point in Class AB. Class D is where it's all going if it's done well. Well, can you imagine this thing here? 2 times 600 watts. That's actually right here. In this case, we have 2 times 1 kilowatt. Well, I hardly ever make these. They're not needed for home use. But just as an example.
Okay, Class A, AB, the classic audiophile choice. It's chosen for its character. What's its problem?
Well, it's big. Big and expensive. It's big and expensive, but it plays the same. People claim it plays better, but it doesn't. Nowadays it doesn't sound better anymore. But it's big and expensive. Let people with a lot of money buy it. Class AB, Class A. And for those of us with average incomes, we'll buy it and get the same sound quality.
And if you compare the price per watt of Class AB and Class D, what kind of imbalance do you get approximately?
You have to look at it a bit differently here. One thing is how much production costs. And another thing is how it's incorporated into the business model. If we look at, well, the business model, here are all the amplifiers up to 100 watts. They used to cost from 250 euros up to, say, 650. 300 watts used to cost from 3,000 to 5,000. And what if it's a kilowatt for home use? Then it cost, I don't know, from 5 to 30, right? And that's how the sales marketing set it up. Those who have money bought the kind that can drive any speaker cleanly, correctly. Big money. And then people were surprised. At home it sounds normal. You come over and, my God, how does it sound so good? Well, it's just a good speaker, that's all. There's headroom. There's a lot of headroom. And making a good 1 kilowatt amp like that is a very difficult task. The Chinese don't make them at all yet. They make them for PA use, but to make one for home use so that it can reproduce at least 500 watts, well, that's expensive.
But the Chinese have flooded the entire market with inexpensive amplifiers where the price per watt is very reasonable.
Well, TPA 32, 55, but they're just eating each other up there. There's another problem here. When too many people are doing the same thing, you make half a dollar there, you can't grow. And you have to start simplifying somewhere, right? Many go out of business, then actually the price of these Chinese amplifiers is going up. It used to be 150, then 180, 200, now it's 250. And now look, 250, 500, it's all the same. They have a better case there, more screens, and they're trying to reach that minimum of 250. Once they hit the minimum of 250, they start to survive. If they manage to sell it for 300 there, you're more involved in that industry. I don't know how much the latest AmpApp and Ivy and so on cost now, but I think they're less than 200.
They're getting more expensive, I totally agree. That's right, but here it seems the Chinese began taking over the market mainly with affordable options. And then they'll start making more expensive products and gradually try to occupy the niche of classic hi-fi.
Well, yeah, they'll go into that niche.
So now they'll earn people's trust.
They'll learn to make, yes, smaller ones, but decent ones. Everyone's already saying, well, they're small, but decent. Yes, not very good, but pretty good.
Yes. Well, I'm completely satisfied with amplifiers like Ampapa D1 or AMA A80. It's inexpensive, looks nice, neat, high quality, and sounds good. I like that you can buy an amplifier for such a price nowadays.
Well, the middle class buys it, yeah.
I remember that I bought my first hi-fi amplifier probably 15 years ago. It was a Marantz PM5005. It cost 329 euros. And its power was 40 watts per channel.
Well, that's a problem with Class AB. If you do it properly, yes, it gets really hot. You need big heat sinks. You have to do everything carefully, use good semiconductors. I would say the absolute minimum without compromises, the price per watt is €1 per watt per channel. So if we're talking about 500 watts per channel, then 1,000 is a fair, honest price.
For a stereo amplifier.
For a stereo amplifier.
Class D.
Class D without compromises.
Uh-huh.
You can make it cheaper, but then you're already making some compromises. In many industries, well, there are the cheaper ones and there are the honest ones. This is the fair price if you want it without compromises, but it can't be cheaper, and I doubt it will be possible in the future.
All right, thermal design.
Well, it still heats up anyway. Wait, just imagine, if it's 90% efficiency, that's 10%.
Of heat.
Of heat. Well, for the small ones, it's always less. There's 80% efficiency. So 20% is heat. The very first TPR 3255, they all heated up. Well, look now, there's already a little bar here and there's something extra there, and the case is a bit bigger, and so on, so on. We're barely making it to 100, right? Well, this one is very good, but still it has about 10-12 watts of pure heat. Well, here we're managing.
With a fan.
With the fan. It spins slowly there, you can't hear it, but there's constant air exchange. Well, many people shouted, I don't like the fan. You know, I hate the fan is bad, it affects things, God knows. So I made it without a fan, right? But I made it in such a way that when you actually listen to it, you turn it and then convection goes from the bottom up.
Ah, so you can place it both upright and on its side, right?
Well, yes.
That's an original solution.
Well, the funniest thing is that, you know, a lot of people were shouting, I want it without a fan, but what do you think they actually buy from me?
With a fan.
Everyone buys the version with a fan, and a lot of people were shouting, without a fan, and I set a lower price, much lower. No, they don't buy the version without a fan. Everyone says they want it without a fan, but they don't buy it. Basically, I don't know my market, yeah, I can be fooled.
We all live, we all learn, and everyone needs to make their own 1,000 mistakes a month in order to move forward. It's a normal process.
Well, basically, this one, well, on its side is the correct orientation. It cools well, yeah. It's just hard to make a box like that. Well.
All right, thermal design.
Yes, it's important.
Oh, this point was also mentioned. Load stability.
Well, yes. Well, basically, it should work with all loads, with 2 ohm loads.
In home audio, there isn't such a load as 2 ohms. There are practically no speakers that drop to 2 ohms.
Oh Lord, almost all three-way speakers drop down to 2 ohms somewhere. Well, if it's done very skillfully, yes, but it's around 500 hertz, 300, where it all comes together. That's where they drop low. Well, 3 for sure.
Yes.
Because before. But modern amplifiers all work with a 2 ohm load, not at full power. And where it's 500, basically you never go full power. You only go full power.
Peak.
Peak at 100. Well, just on this, on the bass register only. So it should be built in such a way that it doesn't oscillate there and no protections are triggered there. Today, all modern amplifiers work into 2 ohm loads. They can't deliver full power. Yes. But in principle, you can crank this little thing without any problems. All modern amplifiers, AB, and that's it.
Protection systems, mandatory and unobtrusive. A good amplifier should protect the system without affecting the sound.
Well, by default, a modern amplifier in any mode, under any operating condition, no matter what mistake is made, it should protect the speaker. Yes, and today modern units definitely do that.
And what if we're talking about Chinese manufacturers who make inexpensive devices and have to cut costs?
Well, you see, when you have a switching power supply, you have protection in 2 ways. Let's say the amplifier unit has completely failed. There's also a second protection on the unit, on the switching power supply. It just won't start. And when it doesn't start, there's nothing there. So with a switching power supply, we can use it without output relays and things like that. A Class AB amplifier is harder to protect. There should also be a relay-based protection circuit, so when everything fails, the relay disconnects. And that's also another step forward in favor of switching power supplies. But that's basically by default. It should have temperature and other protections.
All right. So how can I check, for example, if I'm buying an amplifier on AliExpress, how can I check if it has any kind of protection or not? They don't write anything about it. I've never seen a section about protection in the amplifier description.
You connect it, you don't connect the speaker, you take a wire, you short it. If it triggers, you let go, it works, you short it again. You should short it, and if it shuts off, you send it back and curse them out, saying, how could you release something like this? I don't know, equipment like that shouldn't even be on the market.
No, but am I right in understanding that if I short the contacts, it should turn off?
Yes.
And then, when I disconnect the contacts, after some time it should turn on and keep working?
Absolutely. Maybe you should try turning it off and on again, or it can vary.
Yes, some time should pass. Maybe there will be a delay while the relay is working?
According to the instructions, it's made so that if you short it, nothing will happen to it.
Yes.
That's just standard, it's not even a feature. What if it's not like that?
If I short-circuited it and it stayed on, is something wrong?
Well, then you'll smell smoke.
If it's burning?
It won't turn off.
Yes.
Then it must burn out.
That means everything is wrong. It's best not to connect the amplifier to the speakers, just return it immediately.
Yes, and write really nasty things about it all over the internet.
It's not protected.
They are all protected, and in TPA 3255 the protection is very good and reliable. It's all set up, just do it properly.
So, if we use TPA 3255 and the chip has built-in protection, can we just ignore it?
Yes, you use the standard schematic and everything will work there. If it doesn't work, you have to tell everyone that this is a bad design.
Yes.
Can you imagine the speaker cost a couple thousand and this cheap piece of junk burned it out, right? Yeah.
But you and I mentioned in one video that this cheap stuff is actually competition for high-end products.
No, it's well designed, it works. If some unit doesn't work, then that's below cheap. I don't even know what to call it.
That's a crime.
That's a crime, yeah.
Bad product.
Well, the latest trend is that it's good and versatile. There are different inputs, and if you need to choose, there's a balanced one. Because you can connect the balanced one both to a balanced connection and to a regular one, to a regular unbalanced one.
Uh-huh.
But you can't make an unbalanced one work with a balanced connection.
Well, you can connect it, but there won't be any point in having a balanced connection then. All right. In home audio, balanced connections are actually used very rarely. Mostly RCA is used.
Well, yes, but times change. Balanced is better. Balanced is better, and the cable is easier to get.
Even for home use, will balanced be better?
Well, look, when you're looking at a good, high-quality modern amplifier, it has both balanced and unbalanced inputs. And even digital to analog converters are made with both balanced and unbalanced outputs. Well, that's normal. Because if there isn't an unbalanced output, the person who buys it will eventually have some unpleasant problems or limitations.
Inconveniences.
Inconveniences, yes, inconveniences. For a good one, I'd say you need it.
Okay, fine.
Well, of course, you can live without it, yeah.
Yes.
But for a good one, you need it.
All right, next item. Signal control. What is this? Gain adjustment? 26, 29, 32?
Well, that's if. That's how I would put it. We used to have a standard for the preamp output like 250 millivolts, then 500, then up to 1 volt. A modern preamplifier should deliver up to 3.8 volts on the balanced output as a standard. And then all of this isn't necessary. And if you want both the past and the future, well, then you have versatility.
Triggers and control.
In modern designs, generally, the power amplifier is separated from the preamplifier. Before there was what was called an integrated amplifier. Now there is a power amplifier, more and more. And in this case, it's convenient when you place the amplifier next to the speaker and you have this kind of cable.
To the speaker?
To the speaker. And then everyone knows about this little resistance and so on and so on. If you have balanced cables or even wireless connections, you can control it either via a 12-volt trigger, or there's also signal sensing as a backup. When the signal appears, it
woke up
and everything works. You turned off your preamplifier, your DC streamer and so on. And he fell asleep there, you know. Basically, it's standing on the floor or somewhere in a cabinet. You installed it, you don't see it. That's the moment when you have a big sound stage over there, and here you have this kind of amplifier, and here another kind of amplifier. The amplifier should slowly move closer to the speaker. It's sitting there.
All right, question. Let's say I have a source. By the way, I had such a digital to analog converter, Fosi Audio ZD3.
And you asked for it.
No, I sold it. It's awesome for $200. How much does it cost? It's great. It has balanced outputs. Let's say I have 2 power amplifiers and 2 speakers. How do I connect them properly, according to engineering feng shui? Should I connect the amplifier with a short XLR cable and use a long cable to the speaker? Or the other way around? Run a long XLR cable to the amplifier, place the amplifier next to the speaker as you suggest, and then use a 50 centimeter speaker cable to connect to the speaker? What's the proper feng shui way?
Well, you see, according to feng shui, basically at home you can do it either way and you probably won't really hear a difference. But if you want to do it properly, if you're using a balanced cable, especially with the levels needed for the amplifier, you can run it that way.
They are here, 3.8 is here.
Yes, you can run them, well, at least for 200 meters. Really good, proper, professional ones you can run for 600 meters. That's pretty far.
I don't have anything like that at home.
No one has a home like that. And you won't have any losses and there won't be any hiss. It will be very, very clear. And in terms of speaker cable, well, the lower the resistance, the better. If it's a short cable. And I think that it turns out that it's closer to the speaker.
So your feng shui puts the amplifier closer to the speaker and connects the source to the amplifier with a long balanced cable.
Well, yes, if you have it, it's right here, within reach.
Yes, yes.
You can also control it with the remote then. There's a small cable, but it works differently. But basically, feng shui says that the amplifier should be placed close to the speaker. Some extremists even build amplifiers into the speakers, I've heard.
Yes, there are such extremists. One of our Riga extremists is Roland from Reflector Audio. he builds three-way high-pack amps into the speaker. He also has a DSP module in there and other such tweaks. Alright, let's move on to chapter 5. Guys, please write comments, share your experience, how you install amplifiers, how you set up sources, how you connect speakers, what you think is the best way. This is important. Chapter 5. Design and reliability, the case. What should the case of a good amplifier that will beat everyone be like?
Well, here we have to choose. Either we choose sound quality or we choose a high price and also sound quality. In general, a very good and beautiful case, very beautiful, is expensive.
Like, for example, Dan D'Agostino.
For example, Dan D'Agostino, it's very expensive.
It's very beautiful. When you look at it, it's a masterpiece, a work of art.
Yes. And very often my conversation with the client goes like this. He comes in, well, he saw it in the picture. Well, here it looks more or less okay, right? Wouldn't you like to put it in a very beautiful case? Well, I say, I have a competitor. Look, I'm showing you. There's a very beautiful case. He looks at it. Well, it's twice as expensive. But mine will also be twice as expensive. Which one do you think he buys?
Twice as expensive.
No, he buys mine, which is twice as cheap. He asks for something very expensive, but he's not willing to pay for it. That's the point. When you're selling with such massive marketing, for example, to a different audience where everything looks beautiful and the prices are all high, that's where you can make a sale. But when you have the middle class coming in, and they have to make a choice, because the choice is, well, 1,600 or like 700, right?
Uh-huh.
And suddenly he just can't bring himself to do it, and that's it.
No, well, that's a conscious choice.
Well, look, it's the same concept. If it's standing on the floor next to the speaker, it's small and convenient, well, then it should be purely functional. And if it's in the front, like a status symbol amplifier, well, then it should be beautiful.
Yes.
And again, we're talking about the fact that my audience is the middle class. An educated middle class with whom smart people work seriously.
Pragmatic.
Pragmatic, and those who, well, make money, yes, let's put it that way. But there is also a class that is a bit wealthier, well, above average. These are different owners and so on and so on. Well, everything is fine for them. Their 1,500 is not much. But for the middle class, 1,500 really stings. And you make products like that to hit that pain point, right?
Uh-huh. No, well, pragmatism is good. There's nothing wrong with that. The most important thing is that pragmatism doesn't lead us to some kind of false economy, because if you cheap out, you pay twice.
Well, you just have to understand. And that's why when I develop my own products, of course, there are big, serious companies that make beautiful things, but they have a different kind of client, you know.
Focused on aesthetics.
Wealthier and focused on aesthetics. I had a conversation with a woman who wanted a TV, but it had to be in a certain color and have those wooden parts. We barely found one. Not the best, but it matched the interior. That was the main thing. It was a must. No other TV would be allowed there. Well, that's it.
There are different requirements.
Yes. And those that come in beautiful cases, they exist, and you can buy them for a different price.
Alright, besides the case, we also have shielding, a proper grounding scheme, and separation of power and low signal sections. Tell us what that is, explain it to us. I don't understand any of that. What is it? Shielding, proper grounding scheme?
So when we make the case, we use a material that's metallic. Well, aluminum, iron,
Gold.
gold, copper. Gold is rare. Not with me. Yes. Well, sometimes there's gold. I haven't seen any gold. Okay. In the shape of a spaceship with two gilded wings, right?
Well, in the United Arab Emirates, they even cover cars with gold for prestige.
Well, yes, there can be if they cover the domes.
I'm sure they also have amplifiers covered in gold, with gold cases and diamond attenuators.
So a proper grounding scheme.
Yes.
In general, there's a 20-page white paper from Texas Instruments about how audio systems and amplifiers should be grounded. I can tell you that 90% of professional engineers don't know that. And in this unit, everything is done exactly by the book. Well, and the same thing, if you break it, yes, you might get some background noise. So some incompetent engineer did something there, well, connected or joined something, you need to know about it. And there they also provide the entire wiring diagram, how the grounding is done. And you need to look at this diagram and not do anything foolish.
All right, so how do I determine, let's say I bought an amplifier, how do I know if it's grounded or not? How can I figure it out? I can't just short something out and do experiments like that.
That's the developer's responsibility, not the buyer's.
To the manufacturer, right?
Yes, because when everything is done properly, it doesn't hum. It's absolutely dead quiet.
I was at an audio salon in Riga, I won't say which one so as not to offend anyone, and there was an amplifier there that had terrible hum. A good brand, a good manufacturer, well known and respectable. And yet it was humming. The guys there tried everything. They put some anti-resonance pads under it, pressed it down with something from above just to stop the hum.
Didn't work?
And the attitude was kind of like, well, yeah, it hums. That's just how it is. It hums. So when an amplifier hums, that's not a feature, that's a defect, right?
Well, when we put together the whole chain, starting from the source and ending with the power amplifier, if there's a mistake in any of the devices, yeah. Then you need to find which device was designed incorrectly. Because all of this is documented, engineers are supposed to build it correctly. One mistake and that's it, there's nothing you can do. When we put the cables up on some kind of supports, sure, things may change a little here or there, the angle and so on. No, this is a grounding problem. This is at the developer level. All right, basically the answer is this. If you connected it, there should be complete silence and only the audio signal.
There should be no hum background noise or hissing at all.
Well, a little bit of hissing. Every amp has a tiny bit of hiss. We haven't figured it out yet. That's the amplifier's own noise. But from a meter away, you can't hear it from the speaker anymore. Over there, it's dead silent.
Yep.
If you put your ear up to the tweeter, there's just a little sound, right?
Is that normal?
That's normal. We haven't reached zero self-noise yet.
Yes, that's true. But if you step back a meter and hear nothing, the amplifier is basically fine.
Well, that's how it should be then.
Okay, good. Gunters, please comment on the components, capacitors, MOSFETs, GaN transistors, and so on.
Well, a simple answer. You need to use proper components. As I said, there is a certain standard in the world for this, and any manufacturer has different grades of components.
Uh-huh.
Well, for example, I would look at large storage capacitors, whether they are rated up to 105 degrees or up to 85. Well, a good system should be rated up to 105. Still, it heats up and so on, and you have a big margin. That's very good. But overall, especially, no one really cuts corners on the components. You just need to choose good ones that have passed quality control. There's a big market where that kind of dead stock gets offloaded, and some people make money on them. But I think these ones, no, not here. These blocks are made from surplus stock and leftovers from big projects.
Uh-huh.
Otherwise, you can't hit that price point. So what now?
The parameters will likely fluctuate there.
Oh.
Or maybe they won't?
Well, here, for example, if the resistor is 1% and you didn't get it, you got a 5% one, it's not waste. They just offload them cheaply. Well, here a 5% resistor will work, you know, things like that. Of course, the completely defective ones are thrown in the trash. That's not the case. But in general, this is assembled from bad components. I think this one is built from very well chosen components because the design is complex and good equipment is used. This also relates to the price. Why can't it cost less than €1 per watt? Why can't it cost less than €1 per watt? Because then you start using lower quality components. You start cutting corners.
You start looking for compromises.
Well, yeah, but you have to sell it and make a profit. Yeah, you can't.
Well, let's sum up what parameters and features define a really good amplifier.
Well, everything we've talked about, low harmonic distortion. That's easy to achieve nowadays. Almost everyone does it. And TPA, I don't know, 3255 EL also has in the base 0.006, according to the documentation. Low noise, signal to noise ratio, signal to noise. It's difficult. Not everyone can do it. For example, this one has 600 watts per channel, but its own noise is 30 microvolts. It's very hard to achieve, but they did it. TPA 35, 55, 32, 85, right? Almost 3 times more. But cheaper. Intermodulation, 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 intermodulation. Jesus Maria. The distortion is low too. Almost everyone does it. The damping factor is low. Today, with a single semiconductor, it's simple. It's just a marketing term. We don't need it that low. Flat frequency response by default, yes. Plenty of power in reserve. And I agree, because they really do sound much better if you have some headroom. And then you can move them away from the wall, yeah, and maybe use a bigger speaker. Engineering-wise, all of that works today. Protection, full and transparent protection.
What does transparent mean?
You can explore everything there without breaking anything. If the box is closed, you can poke around everywhere and everything stays the same and nothing happens. It has to be foolproof, protected from any fool. Any little kid who goes poke, poke, light on, off, we do everything. And basically all the connectors should be modern enough. I'd say balanced and unbalanced are a must for the future. Well, to ensure compatibility and reliability. You turn it on, it works, and you forget about it.
Reliability is forever.
Well, yeah, 10 years without any problems. So the cooling system is important. Smart people buy one with a fan or install it that way.
But all your customers are so pragmatic, you see. You make it, people say they don't want a fan, but still they buy one with a fan so everything stays cool and works for a long time.
Well, when he pulls his money out of his pocket, suddenly he wants it not to break. Right? People are like that, you know. Customers are like that.
Complicated?
Interesting. And I think my marketing is educational. When I do my own marketing, I talk about concepts of the future, and people enjoy learning. I don't have those who say, come, set it up, no matter how much it costs. There was one like that, actually not him, but his subordinate called asking if I could do something. Well, when I heard who was on the other end, I said that I don't sell to that kind of audience. Well, you know, working with them is very difficult. And I'm an engineer. I don't have time, you know, to deal with endless conversations with someone who wants everything here and now. For me, when someone places an order, I see the order come in, I make a batch and I send it out. That way I have time for development. Otherwise, I'd need a big sales department.
You have an online store on your website at tcrasters.com. You can go there, click the buy button, and Gunters can keep working on his developments while you just get a package with your high-end amplifier that will blow everything away. And if you're a pragmatic buyer, and I believe you are, then you'll order it with the fan, which will make your amplifier first of all reliable, second durable, and third, it will still be silent. Elegant, very beautiful.
Now this works too, yes. But people kept asking for a long time. I made it and few are buying it. And I set a pretty low price, but people still buy the expensive one.
Because it's reliable here. Cooling makes the amplifier reliable and more efficient, that's good. Well, you see how interesting it turns out. People kept asking, talking a lot, but with their money, they vote for the other one. That means the other one is more important to them than this one. But it's possible that if this one didn't exist from a sales perspective, people would buy this one less because there wouldn't be a choice.
Well, yes, I agree. Basically, when it comes to the art of sales, that's why I listen to a lot of different high-end salespeople. Many people criticize them, saying they're not smart or something. On the contrary, they're smart people, they're good bloggers, and they understand the psychology well. Well, what I don't really support is just lying. The thing is, we live in an information world. Sooner or later, someone will come out and say that this is basically wrong, and your buyer will hear about it too. And you lose something. There's this word brand. Everyone thinks it's just a name, but basically it's trust. But brand is a synonym for trust at the most basic level. And as soon as you lose trust, well, your business falls apart. So I think if you lie, you might be able to sell some cable for a bit more, but it's not worth it. It's better to sell a higher-end amplifier, sell a higher-end speaker. You'll earn more and the client will be very satisfied. He'll forget that he paid a lot. He'll say, wow, it sounds incredibly good. Well, I think you still need to do marketing. That's right, yes.
That's a very good position. All right, Gunther, thank you for the interesting story. Thank you for your engineering skills, for your explanations that help us better understand what quality sound is. And these explanations help us understand which amplifier is the better choice. I think everyone already understands that a 500 watt amplifier per channel isn't needed to run at full power all the time, but to have a reserve. You listen with the knob at 10 o'clock and you always have headroom for peaks. Guys, we're wrapping up here. Visit our websites, YouTube channels, and feel free to ask questions. That's all, and may the force of the sound that's right for you be with you. Paldies, Gunters, par interesantu stāstu.
Paldies.